Hello everyone, welcome back to my channel. In today's video, I'll be trying out some interesting DIY ideas. Here I have a round magnet. I'm going to use this magnet along with some other materials to build a simple signal antenna. I also have a bunch of old bolts here. First, I'll pick 2 long bolts to create the vertical frame for the antenna. I place the magnet on the plastic lid to mark the position. I apply a layer of hot glue onto the surface of the plastic lid. This will serve as the body of the antenna. Then, I attach 2 bolts onto the magnet to form the supporting frame for the signal receiver. I adjust their position to make sure they stand straight and balanced. To secure everything, I use hot glue again to firmly attach the bolts to the magnet. Once the glue cools down, the frame becomes stable and can stand firmly in place. In the next step, I connect the wires for the antenna. First, I strip the insulation from the wire to expose the copper core. Then, I wrap the copper wire around the bolt to create a contact point. I use pliers to tighten the connection, ensuring a firm and stable contact. I repeat the same process with the other bolt. Next, I screw a nut onto the bolt to secure the wire in place, making the connection more stable and preventing it from coming loose. Here I have 2 light bulbs, and I'm going to reuse them as parts for the antenna. First, I use a lamp holder to check if both bulbs are still working. I install the first bulb, and when I turn it on, it lights up normally. Next, I test the second bulb, but it doesn't light up. So, this bulb is broken. Instead of throwing it away, I'll reuse it to create a simple welding tool. First, I use a utility knife to pry open the top of the bulb. Then, I use pliers to remove some parts from the center of the internal circuit board. Next, I drill a hole at the center, preparing it for assembling the welding tool. I use the tip of a utility knife to pry out the internal circuit board. Then, I continue to remove the base of the bulb to expose the inside, preparing it for the heating part of the welding tool. Now I move on to building the welding tool from this bulb. I insert a hex bolt into the hole at the base and adjust it until it fits properly. In the next step, I work on the electrical wiring for the system. This is a crucial part because it determines how well the current is delivered to the welding tip. First, I strip the insulation from the end of the wire to expose the copper core. I twist the wire around the bolt to create a solid electrical connection. Then, I insert this bolt assembly into the hole at the bottom of the bulb, forming the conductive structure for the welding setup. Next, I drill a small hole in the bulb's top cover to pass the wire through. Then, I feed the wire through the hole and close the cover to secure in place. Here, I have a metal connector. This part helps connect the heating tip with the conductive structure, allowing efficient current transfer. I attach it to the bolt, then use a screwdriver to tighten it securely. Next, I reuse an old battery to make the soldering tip. I choose the battery core as the soldering tip because it can conduct electricity and withstand heat relatively well. First, I use pliers to remove the outer metal casing. I use a utility knife to remove the plastic outer layer of the battery. Then, I grip the inner core with needle nose pliers and gently twist to pull it out. I clean the core using a tissue. This will serve as the soldering tip. Additionally, it is easy to shape, allowing me to sharpen it for better precision during welding. After that, I attach the core to a drill to shape it. I turn on the drill and press the tip against sandpaper to sharpen it. Sharpening the tip improves contact precision, making the welding process easier and more effective. Next, I attach the core tip to the metal connector to complete the soldering tip of the welding tool. I make sure the contact is firm to ensure stable heat and current transfer. Then I use an alligator clip as the electrical clamp for the welding tool. This makes it easier to connect and handle during operation. I use pliers to clamp the tail of the alligator clip onto the wire core. Then, I adjust the insulation to cover the connection, improving safety during use. Here, I have a telescopic antenna rod that can extend and retract. I will use it as the main signal receiver for the antenna. First, I connect a small wire to the antenna rod. At the other end, I strip the insulation to expose the copper core. The circuit board of the bulb was pre-drilled earlier, so now I attach the antenna rod to this position. Next, I feed the wire through the hole at the bottom of the bulb. I gently tap the base with pliers to secure the wire and ensure a stable connection. I cut off any excess wire to keep things neat. Then, I place the circuit board back into its original position. I use a hot glue gun to apply glue around the edges, securing the board firmly. I also apply a bit of glue at the base of the antenna rod to keep it stable during use. Here, I have a lamp holder, and I'll use it as the connection point between the antenna and the signal cable. First, I use two small wires as the electrical leads for the socket. I connect the exposed wire cores to the metal terminals inside the lamp holder. Then, I use a screwdriver to tighten the connections, ensuring a firm and stable electrical contact. Next, I reassemble the socket casing to complete this part. At the other ends of the wires, I strip the insulation and split the cores into two strands for easier connection later. Then, I screw the bulb body, which acts as the antenna receiver, into the lamp holder. Both parts fit together, forming a complete unit. At this point, the antenna receiver section is finished. Next, I will mount it onto the frame to complete the assembly. Next, I twist the wires around the two bolts that are firmly attached to the magnet. These bolts not only serve as a structural support to keep the antenna stable, but also act as metal contact points that help transfer the signal from the receiver down into the wiring system more efficiently. Then, I place the entire signal receiver unit onto this frame. I carefully align the contact points and use a hot glue gun to secure each connection, ensuring the structure remains stable and doesn't shift during use. I slightly tilt the antenna rod upward at a certain angle. This positioning helps improve signal reception, especially in environments with obstacles or interference. Next, I complete the power connection by attaching the antenna wires to a two-prong plug. I connect each wire to the terminals and tighten them with a screwdriver to ensure a firm and reliable connection over time. After completing the wiring, I reassemble the plug casing as it was originally. I carefully align all the components to make sure nothing is misaligned or putting pressure on the internal wires. Next, I use a screwdriver to tighten the screw on the casing. This secures the entire plug, keeping the internal connection stable. After finishing, the antenna has a compact and solid design. The frame is stable, the connections are clean and secure, and the antenna rod is positioned to maximize signal reception. Here, I have a signal cable with a female plug and connector already attached. I connect the antenna plug to the female end, forming a complete system that is now ready for real-world testing. Next, I will test the welding tool in a real setup. I use a 12V car battery as the power source for the welding system. During the process, I place a piece of wood underneath as a base to provide insulation and protect the working surface. The positive terminal is connected to the welding clip, while the negative terminal is connected to the ground clamp. When I touch the welding tip to the ground clamp, sparks immediately appear. The tip quickly turns orange due to the high temperature, indicating that the system is working. First, I test it by welding two wires together. I twist the exposed copper ends to create initial contact. I attach the ground clamp directly to the joint to ensure a stable current flow. Then, I lightly tap the welding tip onto the area to start welding. I hold the tip briefly, then lift it and repeat the process a few times to strengthen the joint. After finishing, I pull both ends to test the strength. The joint holds firmly without separating, showing that the weld is strong and reliable. Next, I try welding two razor blades together. I place them overlapping each other and attach the ground clamp to one end. Then, I lightly tap the welding tip onto the joint. The metal at the contact point heats up and melts, bonding the two pieces together. After a few passes, the blades are firmly attached, showing that the system works effectively. For the final test, I will engrave text onto a piece of wood covered with aluminum foil. I attach the ground clamp to one end of the board to create a stable electrical path. Then, I use the welding tool and start moving the tip across the foil surface. When the tip touches the surface, the heat burns through the foil, creating visible marks. I slowly guide the tip to form the word "like." From this test, it's clear that the DIY welding tool works effectively and is capable of handling basic tasks with reasonable precision. Next, I will move on to testing the antenna's signal reception. Now, I'll try switching channels on the TV to see if it can receive any signal without an antenna. As you can see, without an antenna connected, the TV cannot receive any signal at all. The screen shows a no signal message, meaning no broadcast channels are detected. Next, I connect the DIY antenna to the back of the TV for testing. As soon as I turn the TV on, the channels appear almost instantly. The picture is clear and stable, showing that the antenna works effectively. To verify this further, I remove the antenna and reconnect it again. When I unplug the antenna, the signal disappears immediately. And when I plug it back in, the channels return as normal. This clearly proves that the DIY antenna works well in real-world use. So, from simple items like a magnet, bolts, and even a broken light bulb, I was able to create a working antenna. With just a bit of creativity and patience, you can turn discarded items into something truly useful in everyday life. If you found this video interesting and helpful, don't forget to like and subscribe to support the channel. Thank you for watching, and I'll see you in the next DIY videos.